Correct.
People's 211?
Correct.
So in addition to this modeling chart that you created, what was that, about 20 years ago?
I think it was 1996, so about 15 years ago.
Going to, let's see, page 9 of People's 212. Also, the text from the current propofol package insert. Can you describe what's shown here and explain to us your contribution to what is shown here?
So this was the work that was in 1991. So this is the work that's 20 years. If you look at initiation of max sedation, you can read through here. Let me just highlight with the laser pointer. It says here that with the infusion method, there's a certain number of mics per kilo per minute. I'm sorry. And this is the way of starting the infusion, which actually is to be done just for 3 to 5 minutes. That infusion is directly from the modeling that I did, and one of the talks that I gave for many years after this was how modeling and simulation were the basis of these numbers. This 0.5 milligram per kilogram, another way of expressing this, given over 3 to 5 minutes. I will say that my modeling actually said 3 minutes. The FDA, to be conservative, changed it from 3 to 5. But the modeling result that I gave to the AstraZeneca for this was 3 minutes. Here you can see the reduction in the elderly. In the elderly, debilitated, or this term here means ill, patients. And they say here the rate of administration should be over 3 to 5 minutes, and it should be 80%. Now that's kind of a bold statement, because for midazolam, it's thought to be half. An elderly patient needs half the dose. But the modeling that I did said for propofol, the reduction in the elderly was just a 20% reduction. They get 80% of the dose of a younger person. There was some pushback and discussion about this because that was considered to be, gee, the elderly, you can really tolerate that much? But it has stood the test of time. 20 years ago this was put forward, and it has not been criticized. That 80% reduction has stood the test of time. So all of those numbers are directly from modeling and simulation that I did for AstraZeneca in collaboration. It was really a 3-way collaboration with the FDA.
And these numbers came from your computer modeling and your simulations of drug dosaging, again, back 20, 15 years ago.
Absolutely correct. But again, I emphasize anchored in data, anchored in experimental data. Now, same thing here for maintenance of max sedation. Here, all this talk, we're only talking about 3 minutes of drug delivery. For maintenance of max sedation.
Can I ask you if you could just explain briefly what is max sedation?
Oh, thank you. I'm sorry. I should have explained that. Max sedation means monitored anesthesia care. The care that you expect when an anesthesiologist is in attendance and controlling the dose and titrating the dose to produce the right drug effect and monitoring for any signs of toxicity.
What does titrating the dose mean?
Titrating means increasing or decreasing depending on what you see. If you don't have enough drug effect, then you will increase the dose. If you see too much drug effect or you see toxicity, then you'll decrease the dose. So that's what titration is. Titration is increasing or decreasing the dose in response to the observations that you make as you give the infusion.
In addition, Dr. Shafer, to your contributions specifically to the propofol dosaging and the package insert and your modeling and simulations in that regard, since that time, 15, 20 years ago, have you continued to have regular involvement with the FDA as well as make regular contributions to this area of this science?
Yes. I've been a special government employee of the Food and Drug Administration for a number of years, although I didn't get my current package back to them, so I'm not sure if it's currently in force. It might or might not be. But I've worked with the FDA for about 20 years, have numerous colleagues and regular dialogue with people at the FDA. From 2002 to 2006, I was a member of the Anesthesia and Life Support Drug Advisory Committee. That is a committee of scientists and clinicians external to the Food and Drug Administration that the FDA will go to for guidance about new drugs or about old drugs that have problems. So I was a member of that committee from 2002 to 2006, and from 2004 to 2006, I served as the chair of the advisory. Is it called advisory committee or advisory panel? One or the other, but I think it's called advisory committee, and I served as the chair of the advisory committee from 2004 to 2006.
You were the chair of that committee from 2004 to 2006?
Yes.
And as chair of that committee, then what were your responsibilities and duties?
As chair, I was regularly interacting with individuals at the FDA, and specifically with the anesthesia products group, on several problems that arose during that time. And also when there is a meeting, you interact with the people at the FDA to help set an agenda, help establish what material needs to be seen by the scientist so that in a one-day meeting you can make an informed judgment. So I would put together with the FDA material, and they would then distribute that material to the members of the panel for evaluation. It was a fairly close working relationship.
Now, you have used some terminology. I want to ask you about a couple things, and I'd ask you to go slowly.
Sorry.
What is meant by the term pharmacokinetics?
Okay. So the word pharma relates to an old Greek word. It means drug. So pharma anything will be drug something, a pharmaceutical company. So pharma means drugs, and kinetics means motion. So pharmacokinetics is about drugs in motion. So what does that mean? When you give a drug to a patient, it undergoes several processes. There are several motions that apply. The first thing that happens is that if you take sort of if you take a concentrated drug as in this laser pointer, and you pour it into the patient, it gets diluted by the volume, it gets diluted by the water in the patient. So it starts off very concentrated in the syringe, but inside the patient it goes into the blood and it becomes more dilute. And so that's part of pharmacokinetics, the dilution of drug when it's administered to a patient. But it doesn't just go into the water and sit there. The water is really blood, and the blood is in motion. So the bloodstream takes the drug everywhere in the body. As the bloodstream takes the drug and delivers it to your brain, well, if it's a drug that acts in the brain, that's how you get a drug effect. But the bloodstream will also take and move the drug through to the liver. And in anesthesia, most of the drugs that we deal with in anesthesia are metabolized in the liver. So part of pharmacokinetics is saying, okay, what happens to these molecules of drug? They get diluted into the blood, then the blood takes the drug to the liver, and then the liver chews up the drug and renders it inactive. So that's all part of pharmacokinetics. Part of pharmacokinetics is also what happens to the pieces of the drug after the liver has chewed it up. What happens to those pieces? Well, they may go into the blood, or they may come out in the bile. The liver forms bile, and it comes out in the bile, it then goes into your intestines, because that's where the bile goes, and it passes on through your intestines. That's all part of pharmacokinetics. However, the chunks, the pieces of the drug that the liver creates also go back into the blood. And from there they may go to the kidneys. And the kidneys will remove the drug. And that's all part of pharmacokinetics. So pharmacokinetics is about drug movement, drug being diluted into the body, drug going to tissues like the brain I mentioned, or maybe the drug goes into fat and the drug just moves into the fat, moving the drug to the liver, metabolism, and then potentially moving the drug either into the bowel or into the urine.
And Dr. Shafer, it's fair to say this is a highly specialized field of study, pharmacokinetics?
Yes, it's a part of the science of pharmacometrics that I talked about earlier. So pharmacometrics is all the math and science about drug dosing. Pharmacokinetics is specifically about the part of it that relates giving the molecule to the fate of that molecule in the body.
And you are an expert and, in fact, have published extensively in this field of propofol pharmacokinetics?
Yes, I believe I have 19 papers specifically looking at propofol pharmacokinetics.
Specific to propofol?
Specific to propofol.
Have you published any papers with Dr. White?
Oh, yes. My very first paper on propofol pharmacokinetics, the first author was Audrey Shafer. Audrey did the analysis of pharmacokinetics in that paper, so that's her analysis. Paul is the principal investigator on that manuscript, and my contribution to that manuscript was really a little bit of the mathematics and mostly computer programming.
Did you, in fact, develop the software to do the modeling that was relied upon in that first paper you did with Dr. White?
I developed a module of the software. The program was something called Make Model, written by a gentleman named Nick Holford, well-respected scientist in the field. But the infusions, the dripping, in this study, Dr. White had infused the drug, and he had made multiple changes in the infusion rate because he was titrating up and down. To handle all those changes, I had to write specialized modules so that the program could accept a constantly changing drug concentration and changing infusion rate, because the program didn't know how to do that. So I wrote that part of the software. The other part of the software I developed was for what's called a three-compartment model. This gets a little bit confusing, but suffice to say that in the case of propofol, you need a little more mathematics to handle it. And I implemented that mathematics in the software so that Audrey Shafer was able to do the analysis. But the analysis was Audrey's.
And did the module you created for that early paper, did the software run simulations as
Yes.
it relates to the propofol infusion?
Yes.
And what is a simulation, first of all?
Okay. A simulation is taking a dose of drug and saying, if this was the model, if I put drug into this cup, and I'm going to just think that this cup has, I don't know, we'll call it a cup of water, a simulation would be, what's the concentration in the cup? You do a calculation. If I then say, well, I'm going to extract so much drug every minute from this cup, you'd say, well, I can calculate that too. And that's what a simulation is. You project what you think will happen based upon what you know about the body and what you know about the drug. When you are estimating pharmacokinetics, you're constantly proposing a model. By constantly, the computer does this 1,000 times a second. It proposes a model, and then it asks the question, is this model consistent with what you saw in your study? If the model explains what you saw in the study, it's probably a pretty good model. If you propose a model and the model then simulates the concentrations, and those concentrations don't look like what you saw in the study, then it's a bad model. So simulation and modeling are hand in hand. Every time you want to understand if a model works, you do a simulation. And then you ask the question, does the simulation describe what you saw? And if it doesn't, you propose another model that's kind of close. Try to figure out what's wrong, what's right about the model, and what's wrong. And you do that literally thousands of times a second until you come up with a model that describes your data.
Mr. Walden, let us know when it's appropriate to break.
This is fine, Your Honor.
Okay. May I see counsel for just a moment? Ladies and gentlemen, as I indicated, we're not going to be in session tomorrow because of witness scheduling. We're also not going to be in session this afternoon because of witness scheduling. And this is at the request of both sides in the case. And the matter just came to my attention very shortly before we started the session. So if I had known, I would have given you a little more lead time. But we are going to take a break until Monday morning. And I'll give you a little more information in just a moment. At this point, Dr. Shafer, thank you for your testimony. Please don't discuss your testimony and the facts of the case with any other witness until we finish the trial. You may step down and leave. However, you are ordered to come back this coming Monday, the 17th of October at 8:45 a.m. Is that okay, sir?
Yes, that's fine.
Thank you, sir.
Thank you very much.
Thank you. All right, ladies and gentlemen, we are going to take the Thursday and Friday recesses and adjournments this time. And because it's a rather lengthy recess and adjournment, I will, of course, instruct you as to these very, very important admonitions. Yes. Oh, there's a stipulation, I believe. You want to enter to it right now?
If that's agreeable.
That's fine. Now, the parties have agreed to certain facts in the form of stipulation. And Mr. Waldron will read it. Do you want it? Is it going to be written and also as an exhibit or not?
It's a written exhibit.
All right, 213?
Yes, Your Honor.
All right. There's a stipulation in writing. That way you don't have to feverishly start writing everything down, but you can as it's being read to you. Stipulation mark 213. Mr. Waldron.
And just for everyone's benefit, this relates to previous exhibit, People's 167, the fingerprint stipulation. It's supplemental to that. People's 29, known as LAPD item 110, the saline bag with cut, was examined. A total of 4 latent prints were recovered from the saline bag. The 4 latent prints were located in the areas marked by the black lines on the saline bag. The prints were identifiable, however, no identification was made from the prints.
Stipulated by the people.
Yes, Your Honor.
By the defense, Mr. Chernoff?
This is a stipulation we'll agree to.
Thank you. The stipulation is accepted by the court. As I mentioned to you, ladies and gentlemen, when the parties stipulate, that means they accept the facts as true, and the jurors must as well. And so this stipulation is in writing. You'll have it as People's 213. Can I do my thing now, Mr. Walker?
Of course, Your Honor.
Mr. Chernoff?
Yes, Judge. Thank you.
Ladies and gentlemen, please follow these admonitions, and you can repeat them after me because you know them, and in fact, you can mouth them along with me. Do not discuss this case among yourselves or with anyone else, or form or express any opinions about this case until it is submitted finally to you. Do not visit any scene or location that may have been referenced, mentioned, or involved in the case. Don't perform any experiments, or on your own or through another person, conduct any independent investigation or research on any topics, subjects, or persons mentioned or involved in the case. Do not come into contact with any television or radio programs, newspaper or magazine articles, or books regarding any of these topics, subjects, or persons. Don't access on your own or through another person any internet websites whatsoever, including but not limited to any search engine sites such as Google, Ask, or Bing, or social networking sites, including but not limited to MySpace or Facebook, or text or tweet, or access any blogs, or post any messages on any sources regarding any topics, subjects, or persons mentioned or involved in the case. Please have no contact whatsoever with the defendant, the attorneys, the witnesses, or spectators. Don't allow anyone to approach you to enter into any discussion regarding any topics, subjects, or persons mentioned or involved in the case. Don't allow any person to provide you with contact information so that at a later point in time you can contact a person or organization with regard to this case. If anyone tries to contact you in this regard, immediately cease the contact or conversation and notify the court staff and security. Once again, do you assure us and promise us that you will follow your written admonitions as well as my continuing verbal admonitions? Yes. Ladies and gentlemen, thank you. We're going to ask that you rejoin us this Monday, the 17th of October, 2011. Hopefully, we will continue to have triple-digit temperatures in beautiful Los Angeles. Between now and then, it's very hot outside, so please keep cool and enjoy your day off tomorrow where you are free to go back to work or take care of any business or other professional responsibilities you have, or as well as any personal matters that you have. And enjoy your weekend as well. We'll be in recess till 8:45 a.m. this coming Monday. Have a good day off and a weekend off. Bye.